In this video, I will discuss regarding two types of currents. One is drift current and diffusion current. Diffusion current. So let us see what is meant by drift current and diffusion. First of all, we will discuss regarding drift current. Okay. First of all, we will discuss regarding drift current. I will discuss regarding drift current. Okay. So what is meant by drift current? Let us take a piece of semiconductor. Let us take a piece of semiconductor. Okay. So without application of any external voltage, the semiconductor will act as an insulator. At 0 degrees Kelvin, semiconductor will act as a insulator. Okay, so at 0 degrees Kelvin. Okay. So whenever you apply some external voltage for this semiconductor, whenever you apply some external voltage, means that's also semiconductor number of electrons is equal to number of, let us consider these are electrons. Electrons. Okay. Here I am discussing regarding electrons. Okay. So here in my videos, this type of notation, this thick circle is called as electrons. This one notation is holes. Holes. Okay. So whenever I apply supply voltage, some external voltage. Okay. So what is the nature of the electrons? Electron is negative in nature. Whenever I have applied the positive voltage, okay, so the electrons are having negative nature. So always like poles will repel and unlike poles will attract each other. Okay, so they drift. Okay, so they will attract it towards the positive terminal of the battery. Okay, means these electrons will drift towards the positive terminal of the battery. Okay, so sometimes while they are moving, they will collide with the stable atoms, even though then they will change the direction, but due to this applied voltage, again they will move in same direction. Okay, so the drift current means the current which is obtained, the current which is obtained due to drifting of electrons, drifting of uh, electrons due to applied voltage, due to applied external voltage is called drift current. Is called drift current. Means here the electrons are moving in this direction. Electrons are moving in this direction. Electrons are moving. So the always remember that the conventional current direction is in opposite direction. So the conventional current will always move in this direction. So this is the conventional current direction. Conventional current direction. This is electron movement direction. Electron movement direction. Electron movement. So this is one type of current that is called as drift current. Okay. So let us see another type of current that is diffusion current. Another type of current that is diffusion current. When we will get this diffusion current? When we will get this diffusion current? So we will get this diffusion current. Here we are not applying any external voltage. Okay. So diffusion current we will obtain without applying any external voltage. Okay. Let us see in which case. Okay, what is meant by diffusion? Let us take, for example, let us take a pure semiconductor. Okay. So let us take a pure semiconductor. In a pure semiconductor, that is the condition number of electrons is equal to number of holes. Okay. So at this end, for example, if I consider this is the length of the bar, okay. So x is equal to 0. So on the x-axis, this consider, let us consider the length of the bar is L. Okay. So at the starting means that is left side. Okay, the left side of the bar. Here I am adding some impurities. I'm adding some impurities. Okay. So what happened here if I add some impurities? So here let us consider these are holes. I have as well. Let us consider I have added electrons. This thick symbol. Okay. At one side of the bar. At one side of the bar. Okay. So since I have added here impurities, okay, for this pure semiconductor. So if you observe here, in this diagram, here the intensity of the electrons or the charge carriers, either maybe electrons or holes. Okay, the concentration of charge carriers at x is equal to 0 is more when compared to x is equal to L, since the length of the bar is L. Means here the concentration is more. Here the concentration of the charge carriers is more slowly. So after some time, since these are all the charge carriers, for example, let us consider these are electrons. All electrons very near to each other. So negative charge, what happen? Repels. Slowly the electrons starts moving from, means here if you observe here, the electron or the charge carrier concentration is higher concentration when compared to here it is lower concentration. Lower concentration. So what happened here? Like poles, all the electrons are at the same time. Let us consider at the left side, one end of the bar. Since I have doped, I have poured impurity materials here. What happened now? Here the more concentration of charge carriers are there. So since they are like poles will always repel each other. So they start moving from a higher concentration to lower concentration. Either it may be electrons or holes. Okay. So there is a movement of charge carriers from movement of charge, means if I draw this diagram here on the x-axis distance, okay, on the y-axis concentration. So at x is equal to 0, there is higher concentration. So laterally the concentration is red. Okay. So since here the higher concentration is there, repulsion takes place after some time. Okay, they starts moving from higher concentration, movement of charge carriers, from higher concentration to lower concentration, lower concentration. Okay. So whenever there is a movement of charge carriers, okay. So whenever there is a movement of charge carriers, automatically current comes into picture. Okay. So here the movement of charge carriers is nothing but current. Okay. So the type of current, okay, the current that is obtained, the type of current what you are obtained due to movement of charge carriers from higher concentration to lower concentration, movement of charge carriers from higher concentration to lower concentration, such type of current is called as diffusion current. Such type of current is called as diffusion current. Okay. Diffusion current. Okay. So what is the definition of the diffusion current? The current that is obtained due to movement of charge carriers due to non-uniform concentration. Okay, so there will be movement of charge carriers due to non-uniform concentration. So charge carriers move from higher concentration to lower concentration. So this movement is, whenever there is a movement of charge carriers, automatically current comes into picture. Here you are not applying any external voltage. Here you are not applying any external supply voltage. Okay. So whereas in drift current cannot exist without application of some external voltage. Diffusion current, there is no need of external voltage. Okay, so if there is non-uniform concentration, automatically charge carriers move from higher concentration to lower concentration. Thank you.